Assalamualaikum warahmatullahi wabarakatuh everyone. Today we will be presenting our model, the Hourglass. Hourglass is a device used to measure time, made of two glass bulbs connected by a narrow passage where Sains flows from the upper to the lower bulb. Its shape is narrow in the center and wider at the top and bottom, like two cones joined tip to tip. This shape can be represented by a hyperbola in analytic geometry because both have symmetrical open curves. As we can see in the graph, the center C is the midpoint between the vertices V, forming the narrow part of the hourglass, while the foci F help determine how wide the curves open. The asymptotes show the direction of the curves, modeling the smooth hourglass form. The material that we use to construct the cooling tower are hot glue gun, bottle, scissors, cardboard, and fan.
The reasons why my model is suitable in use hyperbolic shape. First, constant pressure. The hyperbolic shape is the only geometric form that maintains constant pressure at the outflow neck by ensuring the height of the sand column above the neck remains constant throughout the emptying process, which is the requirement for timekeeping. Secondly, narrowing waist. Narrowing waist causes the cross-sectional area of the sand to decrease as its level drops. This shape is worked against the natural tendency for the flow to slow down. Lastly, hyperbolic shape also can make the flow rate is also constant. At the top, it might be slightly more rounded to help initiate the flow. At the bottom, the flow may break up, but flow is remarkably consistent, so the shape ensures that pressure doesn't diminish over time.
A hyperbola has its center at the origin and transfer axis along the x-axis. The vertices are at 5, 0 and negative 5, 0, and as per the foci at square root 34, 0 and negative square root 34, 0. So I highlighted the important stuffs with the green highlighter, as you can see. So the question asks us to write the equation of the hyperbola. So the equation shown is actually the example of the equation of the hyperbola. We already have the value of A, which is our vertices. But how about B? How to get B? We need to do some calculations. So we need to derive an equation from C squared equal to B squared plus A squared, where we need to change B to be as a subject formula. As for C, we already have the value, which is our foci. So substitute both values A and C, therefore we will get B equal to 3. Then substitute everything back into the original equations. Therefore, we will have x squared over 25 minus y squared over 9 equal to 1. Let's move on to the second question. It asks us to find the equation of the asymptotes. We all know that the equation of the asymptotes is y equal plus minus b over ax. Since we already have the value for A and B, just substitute those values into our equation. As for the first equation, we will have y equal 3 over 5x, and the second equation is y equal negative 3 over 5x. Super easy, right? The third question asks us to determine whether the point 7, 3 lies inside, outside, or on the hyperbola. So it is important for us to know that if the sum of the equation is equal to 1, it means the point is on the hyperbola. If it is less than 1, it means the point lies inside the hyperbola. And if it is more than 1, it means the point lies outside the hyperbola. 7, 3. What are those numbers? Those numbers are actually our values for x and y. So we need to substitute those values into our equation. Then we will have 34 over 25 as our answer. Is it less or more than 1? It is actually less than 1. Therefore, the point 7, 3 actually lies inside the hyperbola. Super easy, right?